Welcome participants. Now we are moving to lecture number 2 in knitting calculation category. So today the topic is the production, the fabric production in circular knitting machines. Just a quick recap what we have covered in the last lecture. We have seen like the yarn count that could run on the machine is directly proportional to machine gauge square. So this is the relationship we derived in the last class. We have also seen like for different types of technologies in circular bed and in flat bed, the proportionality constant can be different. For example, in single jersey the proportionality constant is 1 by 20, for rib it is 1 by 6. Again these type of proportionality constant, it is empirical in nature, it again comes from the knitter experience. So they have given this useful relationship so that when you have a particular machine and when you have a particular yarn count, you can cross check using this formula that can whether that yarn is suitable to run on the machine, yes or no. So this useful relationship we have covered in the last lecture. Let us move to the next lecture which is production on circular knitting. So production is no doubt is the key thing from a manufacturer point of view, because no matter whatever technologies you are using, they will be mainly focusing on the production in terms of meter or in terms of weight, because they have to sell the fabrics. So they want to exploit the full whatever technologies that is available in their arena. So in circular knitting you have seen so many technologies are available. So in this section we will see how we represent the production in circular knitting and what are the machine parameters that are used to calculate the production directly. In case of circular knitting, you have seen the demo also. So this is how the cam was rotating and the cylinder was stationary here. So the production is no doubt it will depend on how fast the cam is rotating here, because if it is rotating at very fast speed, the loops will be formed faster. You can see here it is rotating in a very slow speed, so naturally the production will be lower. So in production there are two categories where we generally connect each other. One is speed, because whenever we are looking to any of these circular machine, speed is very important, and the speed can be expressed by three parameters. One is machine revolution per minute, which is in normal terms it is denoted as RPM. So any circular motion this term is quite useful. The second is circumferential speed, how fast it is rotating around the circumference, it is expressed in meter per second. And the third is speed factor, which is the relation of RPM and diameter. So if you multiply the diameter of the machine, especially the cylinder, and the RPM of the machine, you get a speed factor. This is also sometimes very useful. And in terms of production, again depending on the capacity of the machine, either its RPM or speed, we can relate the fabric production, which can be expressed in linear meter per hour. So how many meter of the fabric which is being winded from the bottom side, or kg per hour. So how many weight of the fabric is produced per hour. So especially depending on the speed, you can connect production. So there I am going to derive some useful relationship where you can connect speed with the production, and there are some other machine parameters. If you give, there is a very useful relationship through which you can calculate the production, and then you can confirm with the actual production. So this relationship is very useful. In circular knitting you might have seen both single feeder machine and multi feeder machine. So in single feeder machines you can see just there is one feeder, and the cam is taking that feeder across the circumference and needle is catching that feeder. So in one rotation here only one needle is making one loop, but again to increase the production we can go for multi-feeder machine. Here you can see there are so many bobbins attached here, and each and there is a separate feeder zone, and you can see here these are the feeders 1, 2, 3, 4. So, along the circumference there are multiple feeders are present on the machine. This is again for very fast productions, because when the machine rotates, the needle can catch feeder from one cam position to second cam position. So, in same rotation each needle will be making multiple number of loops in case of multi feeder machines. So, you can see here this again this is rotating, here the cylinder is rotating and the cam are fixed. So, whenever one needle is moving from one cam position to other cam position, it will be catching yarn. So, within the same circumference it can makes multiple number of loops, which will depend on the number of feeders. So, this is just the summary. So, in single feeder machine, in one rotation, especially in this machine, one rotation one course will be generated, but in multi feeder machines, in one rotations the needle can do, each needle can do n times knitting action. So, n course can be formed. So, n is the number of feeders. So, again the number of feeders will be equals to number of cams as well. So, this is how we will be looking at the two different technologies, and we will try to calculate the production in both of the case. So, the key take point is, in one rotation here you can make just one course, but here you can make n courses. So, the production naturally will be very faster. So, let us see what are the machine parameters that is useful in deriving this production relationship. We have we will look to each of these machines separately. So, let us focus on first single feeder machine. So, this is the single feeder machine, and we need to first learn how we can express the speed. So, in reality whenever you go to any manufacturer, you will usually get the diameter of the machine. So, whenever machine manufacturer sells the machine, it will give you the diameter value. So, the machine diameter will be always known to you. So, let us suppose this diameter is d, okay, and it is expressed in inches. Okay. So, the unit of diameter is inch. The second thing which is quite the value which is given by the machine manufacturer is the machine RPM. So, it is rotation per minute. So, this is the circle and the cam will be rotating around the circle. So, it means how many rotation, full rotation it is doing in 1 minute. So, that is the rotation part. So, this is let us suppose this is given in R. So, with using these two we can calculate other speed for this machine is the one speed which you which is also related to in circular motion is omega, which is known as angular velocity. So, if you see this class 12th standard book, you will be knowing omega. Omega is the angular velocity. It means rate of change of angles per second. So, because if you sit somewhere at the center and if the carrier is moving, so every second the carrier will be changing the theta. So, the angular rotation is d theta by dt, rate of change of theta. So, that is angular velocity, and this angular velocity and r are connected. So, in one rotation you know there are 360 degrees. So, if you know the value of r, you can connect w. So, the angular velocity is omega is equals to 2 pi, because in one rotation you will be moving 2 pi into r. Okay. So, this will be radian per minute. If you want to express per second, then you can simply divide by 60 radian per second. So, one speed which is used is RPM, the second speed is angular velocity, and the third speed is circumferential speed, which is generally expressed in meter per second. So, this is V, it is expressed in meter per second. So, if you want to connect velocity, diameter and rotation, RPM, the relation is V is equals to omega into radius, and radius is nothing but omega into d by 2, because the diameter is known to us, omega into d by 2. And omega, if you want to connect velocity and RPM, the circumferential velocity, the unit is meter per second, you can simply substitute here. If the omega is in meter per second, 2 pi r 60 into omega d by into d by 2. So, 2 pi r 60 d by 2. So, this is the relation of circumferential speed. So, in reality the most commonly used is RPMs. With the help of RPM we can find out the angular velocity as well as circumferential speed. Let us see one of the simple example. So, find the machine speed. For example, if you see here, find the machine speed in meter per second. So, unit is very important. So, I suggest you always focus on the unit properly, because this is very important. Find the machine speed for a circular single bed machine of diameter 30 inch. So, diameter is given and RPM is 40 RPM. Okay. So, if this is the value, you can simply use this formula, V is equals to 2 pi r 60 d by 2. So, V is equals to 2 pi r 60 into d by 2. Okay. So, you have to be very careful with the unit, because here the velocity is asked in meter per second and your RPM is given is 40 RPM. So, R is equals to 40 RPM, D is equals to 30 inch. Okay. So, you can convert inch into meter. So, 30 into 2.54, this is in centimeter, 30 into 2.54 divided by 100 into meter. So, this is the D. So, you can simply put everything here and then you will get meter per second. Okay. This is the unit in meter per second. So, 2 pi into this is 40 divided by 60 into 30, you can we are putting D directly in meter. So, 30 into 2.54 divided by 100 into 2. Okay. So, 2 pi 40 60 30 into 2.5 100 into 2. So, this if we will solve it, this diameter is in meter, radian r is in rotation per minute. So, we have converted this into second, minute has already been converted into second. So, that is why meter per second. So, once you solve this, pi is equals to 3.14. So, pi is equals to 3.14. So, if you simply solve this, you will get 1.59 meter per second. The speed is 1.5 meter. So, in 1 second it is travelling 1.59 meter on the machine. So, if you know the machine gauge, you can be able to find how many needles it is travelling in 1 second or it is interacting with 1 second. So, in 1 second if you know the machine gauge, you can count number of needles because the length is given, then you can say how many loops that can be formed in 1 second. So, this is the simple example which I wanted to show to you. Now, let us move to the production part. So, this was speed. So, this is all related to speed, this is machine speed. Now, we want to see how much fabric that can be formed on this machine in terms of meter or in terms of kg. So, for that we need to first define certain symbols. So, machine speed we are representing in RPM, which is in rotation per minute. Okay. Number of feeders is n. N is equals to 1, it means single feeder. Single feeder machine, which we have I have already shown you. N is greater than 1, then it is multi feeder. Okay. So, in single feeder machine, one rotation, only one course will be formed. In multi feeder machines, more number of course will be formed in one rotation. So, number of feeders is known. The fabric produced, we can measure its course per inch, course density, which is C. So, number of courses per inch. So, if you have the fabric, for example, this is the fabric, you can measure the number of loops per unit length. So, that is course per inch. So, if you remember the first lab demo, I have shown you in the first week also we have described this thread density. So, course per inch is C, and machine efficiency. Machine efficiency, because when you start running on the machines, you have seen we use the machine by hand and sometimes computerized machine is also used, but not all the time the machine will be used. There will be some downtime, means like for example, if the labor goes for T, then he has to stop the machine. So, in that case you are not actually 100% all the time you are using the machine, you are also underproducing or the potential of the machine. Or maybe if let us suppose while running the machine, if the thread breaks, so again joining the yarn on the machine, it will take some time. So, some part of the productivity will be lost. So, machine efficiency is E. So, we denote it could be like 80%, 90% of the time it is running perfectly. It is very rare that the machine will be running 100% of the time, because there will be always break. It may be tea break, there may be also some problem with the fabric productions, the yarn may break, and there could be a number of other possibilities can happen. Because of that, the efficiency will always be less than 100%. So, if you know this, these are the very common practical values which you can always find. So, machine speed already given by the manufacturer, you know that. Number of feeders you can easily count, course per inch, the fabric which is being formed, anyways you will do the analysis, so you can find out the course per inch, and the efficiency you can expect. If it is more, it is good for the company, if it is less, this need to be improved. So, once you have all these 4 parameters, you can find out how much fabric that you can produce per hour. So, fabric production, which we can describe in length of fabric per hour. So, length of fabric per hour. So, it can be expressed in meter per hour. Okay. So, if you carefully see the machine, if you go and see the lab demo, we have shown you. So, this was the cylinder and the fabric was being formed like this. So, this is the length direction and it was wrapped at the on the spool. So, this is the length direction. So, the fabric was formed on the knitting zone. So, here the needles was performing, and after the knitting zone the fabric was being formed and pulled by dead weight, and you roll the, sometimes you roll the fabric on a cylinder. So, this is how you produce the fabric. So, this is the length of the fabric which we are talking of. So, we can relate this production length of fabric per hour with all of these variables. So, if you want to find out what is the how much the fabric length can be produced in an hour, you need to find out how many courses that it is producing in 1 hour. So, we have seen machine speed is r. So, in 1 minute r rotation is done by the machine. Okay. And we have seen in one rotation n courses can be formed. Okay. So, one rotation n courses can be formed. So, in r rotation, because in 1 minute r rotation is happening. So, in 1 minute r rotation is happening. So, it means n into r courses are formed per minute. Okay. So, in 1 minute n into r courses has been formed. So, you can find out how many courses can be formed in an hour. So, in 1 hour, because n into r courses are being formed in 1 minute. So, in 1 hour n into r into 60 courses. In 1 hour n into r into 60 courses is being formed by the machine. So, you know the total number of courses, you know the course per inch. So, in 1 inch length of the fabric has C course. So, if you have to this number of courses, you can find out the fabric length. So, 1 inch length has C courses. So, C courses has 1 inch length. So, naturally, so 1 courses will consume 1 by C inch length. So, you can convert 1 by C inch into meter. So, this is equals to 1 by C into 2.54 divided by 100 meter. So, 1 course is consuming this much length of the fabric. So, you have produced n into r into 60. 1 courses has 1 by C inch length. So, this is this much. So, n into r into 60 courses is equals to 1 by C into 2.54 divided by 100 N into R into 60. Okay, this much meter. So, how much time we are taking to make this much courses? 1 hour. So, in 1 hour we are producing 1 by C into 2.54 100 into N into R into 60. Okay. So, this is the production. So, we can, so this is the actual production. We are assuming that the machine is running for entire 1 hour, but since we know we have the efficiency E, not in 1 hour there must be some downtime. So, you can simply multiply. So, total production is in meter per hour is equals to, we can simply multiply this by efficiency. So, 1 by C into 2.54 divided by 100 N into R into 60, and we can multiply this by efficiency E by 100, because efficiency is given in percentage. So, 95 means 95 by 100. So, we can simply get, if we solve all of these, so this will be N into R into 1.524 C into 100 into E. So, this is the formula. So, you can see how the production is connected, if you see this, the total production is connected with N. You can see here this is N, machine is speed RPM, this is some constant, C is the courses per inch, and E is the efficiency. And all of these terms you can find out experimentally, and with this you can find out the productivity of the machine. So, this is the meter per hour. Now, sometimes we can also express the production, we want to express production in kg per hour. Okay. So, sometimes we can express the production in kg per hour. So, for that to find out the production in kg per hour, we need other variables, for example, because we want mass. So, definitely yarn text should be known. So, yarn count, it should be T in text. If it is known to you, you can convert this meter per hour into kg per hour. You also want to know machine diameter in inch, and G is the machine gauge, needles per inch, and L is the loop length in mm. So, if you have additional 4 values, because this will be known to you, we will be knowing what count you are using, you will be knowing machine diameter, machine gauge, and loop length which you can measure. So, with this you can also find out the production in kg per hour. Let me derive for you. So, you know the production in meter per hour. So, this is N into R into 1.524 into E divided by C into 100. So, in 1 hour this much meter of the fabric has been produced. So, if we need to find out how many loops are being produced. So, this much meter is known to you. So, in 1 hour number of courses you can find out n into r into 1.524 into E C into 100 number of courses. This is the length of the fabric, and if you multiply by C, because this is the length of the fabric and you know the course per inch. So, number of courses can be simply calculated by the length into courses per inch. So, you can convert into centimeter 2.54 into 100. Okay. So, this in that case C and C will be cancel out, this and this will be again cancel out 0.6 and this 100. So, this will be you can see in 1 hour ER 60. So, here ER R into N and E is the efficiency we have just multiplied E by 100. So, that is why this is exactly same. So, here we have used the efficiency in the beginning itself. So, we know the number of courses and we need to count how many loops are there in one course. So, number of loops you can find out if you know the machine diameter and if you know the machine gauge, you can find out the number of loops, because number of loops in one course will be equals to number of wales, and each wale is made by one needle. So, each needle will be making one wale. So, in one course if you count the number of needles, that will be equals to number of loops in one course. In one course. So, so this will be pi d, this is the circumference of the machine into machine gauge, G is the machine gauge. So, this is the number of loops in one course. So, total loops formed in 1 hour, you know how many courses has been formed, and this is the number of loops in one course multiplying the circumference into gauge, because this will give you number of needles, and each needle will be making one loop. So, if you count the number of needles along the circumference, they will be making number of loops in one course. So, if you multiply this E R N 0.6 into pi d G. So, we multiply this and this. So, we get it here. So, total length of yarn. So, if you know the loop length, you can say what is the length of the yarn used in making one loop. So, total length of the yarn in 1 hour, because in 1 hour you are making so many loops. So, you can simply multiply by L, and L is the loop length, L is loop length, L is loop length. So, total length of yarn in 1 hour is ERN 0.6 into pi dg into loop length. This was in mm, so you can convert into meter. So, here 1000 is for meter. So, you have the total length of the yarn, you know the text of the yarn, you can get the weight, because this is the total length of the yarn which is used in 1 hour. So, if you know the total, you can find out the total weight of yarn used in 1 hour. This will be the production actually, because this is the total weight of the fabric. For that, so this will be 0.6 pi dg ERNL divided by 1000, and if you know the yarn tex, so tex is equals to gram per kilometer. So, total, this is the total length in meter. So, you can simply multiply this tex is in gram. So, T is the tex divided by 1000 meter. 1000 meter has this much gram. So, you can convert this gram again into kg. So, if you just multiply with this, you can get the production in. So, 0.6 pi d g e r n l t into 10 raised to the power minus 9. So, production, this is nothing but the production in kg per hour. Although it looks very complicated, but if you simply follow the process, you can easily get the values. Okay. So, here you can see how many parameters do you need to find the fabric production in kg per hour. Now, let us do a very simple example and then we will finish it here. For example, if you see this, calculate the length in meter, of a plain single jersey fabric knitted at 16 courses per inch and 26 inch diameter 28 gauge circular machine having 104 fits. So, n is equals to 104, diameter is equals to 26 inch, C is equals to 16 courses per centimeter, machine RPM is equals to 229, efficiency is equals to 95%. These are the values given to you. You can directly use the formula. This is the formula. So, production in 1 hour, this is the formula, this is the total production in meter 1 hour. So, N into R into 1.524 C into 100 into E. Okay. So, production in 8 hour, N into R into 1.524 C into 100 into E into 8. Okay. This one in meter. So, all are in meter. So, you can simply get these values. So, N is 104, R is 29 into 1.524, E is 95, C is your 16, if you know C is 16 into 100 into 8. Okay. So, if you simply get, this will give you 859.56 meter. So, this is the, with this you can actually find out the productivity, since other values are also given except yarn tex. So, if you know the yarn tex, D, machine gauge and L, then you can also calculate the production in kg per hour. So, depending on the questions or depending on the requirement, you can use this useful relationship and match with the reality. So, with this I want to summarize this lecture. So, these two formula is very important. So, one is production in meter per hour. So, this is the key parameters from machine and the fabric, and you can find out the production in meter per hour, and also you can find the production in kg per hour. So, we have derived this. I expect you to do this derivation by yourself. You do not have to remember this formula. If you have understood the concept, you can easily find out by yourself. Production somehow very important. because from the manufacturing point of view, you can anytime you can increase the RPM, and you can also select for higher number of feeders. But in terms of quality control, there are some glitches. If you increase number of feeders, then there are obviously you are controlling more number of yarns. So, but handling more number of yarn can cause breakages, but so efficiency will go down. So, the machine efficiency, machine will be stopping very frequently. If you see the RPM, if you increase RPM, P will also increase, production will increase. But since if you are increasing the RPM more and more, it will be hitting the butt and the cam frequently. So, more and wear and tear of the machine. So, there may be chances of butt breakages or needle breakages. So, E can decrease. So, you have to play with the feeders as well as RPM, so that you can run the machine smoothly. So, in reality, the highest speed which has achieved is around 2 meter per second for circular knitting machine, single feeder machine, and the average speed is around 1 to 5 meter per second. So, now you have seen how these small equations can give you so much information about machine productivity, and you can in the assignments you can do more practice for exploring these equations. So, with this I am ending here. Catch you in next class. Thank you very much.